Good morning, dear students. We have already seen some topics in wave optics, and today we are going to see the Hygens principle. Okay, Hygens principle is nothing but we have already seen different types of wavefronts. Okay, in that depends upon wavefronts how Hygens principle is defined. That is what we are going to see. That before that, we'll just see a recap on the previous things. So,
and spread outward along the surface. When these ripples reach a point on the surface,
you can see here when a pebble is thrown in the pebbles thrown in here, it is created as a wavefront. Okay, so these wavefronts oscillate in the same phases. Okay, so when it oscillates in the same phases, onward. When it oscillates in the full phases, this front phases, it is considered as the wavefront. This is called circular wavefront. Okay, the locus of the waves are connected together and it shows a circular wavefront, and it travels as speed as the wave how it propagates. That is the speed of the propagation. And perpendicular line which is drawn to the surface is called wave propagation. Okay, that the wavefront that we have already seen. Okay, propagation of wave. It propagates perpendicular to the direction of the wavefront. Okay, so the waves while it's propagating, how fast it propagates means if you consider this as a light, it propagates the speed of a light. If it considered as the water, it is moves as speed as of the water. Okay, so and that if it is in the water surface, it is like a circle, and if we see this in a three-dimensional surface, it is a sphere, spherical wavefront. Okay, this we have already seen. Just I want to make sure that you understand by a three-dimensional view of it. Okay, homogeneous and isotropic medium. Homogeneous means the medium should be same. That means air means the complete medium should be air. The wave propagates completely on air. And if it is water means completely it should be water. Like this, the medium should be same. Okay, so while it propagates, can you see here? It is propagated like a small light source, and it is created as a full waves, and the spheres which is created, each of the logo which is joined together, and it forms a spherical wavefront, right? So spherical wavefront is considered like this, stage by stage spherical wavefront that you can see like this. Okay, so this is spherical wavefront. When it comes to a lens, as a small portion of the lens is considered as a straight line that we have already discussed. Similarly, here also the spherical wavefront, a small portion is considered as the plane wavefront. Okay, so here the spherical wavefront, a small portion of it is considered as the plane wavefront, while it's propagate like this. Okay, this is how it propagates. While it's propagating, we call this as a rays. Okay, rays are propagating from one particular point to another particular point. It is moving continuously. Okay, so while it is moving, the plane wavefront and spherical wavefront are propagates with a particular time t interval t. So it is originating in one particular point and it is propagating in the simultaneously in the same way, whether it is spherical wavefront or the plane wavefront, while it's moved like this. So Christian Hygens says that the shape and location at t is equal to 0. The time when it starts, the time is equal to 0. Then the shape at location at t, that is what he consider for the wavefront to originate from one place to move to another place. Okay, so according to Hygens principle, each point of the wavefront is a source of a secondary disturbance and generates spherical secondary wavelets. Okay, so which speed out in all directions with the speed of the wave in the medium. How the wave goes, same medium it goes. If a tangential surface common to all these secondary spherical wavefront is drawn, then it gives the new position of the wavefront in the later instant. So this surface envelope of the secondary wavelets. Now you can see the same thing in an animated form. How? For example, this is the wavefront which is originated from the disturbance sources. Okay, so each of this is a wavefront. So let us consider this A and B as a wavefront. Each point of this wavefront creates another wave from this particular point. It originates this, each of the points acts as a secondary wavefront, and the waves are originating from each of the point. So each of the point, if the waves are propagating, it will overlap. Okay, it will overlap at this particular position. Okay, so and moves like this. The speed of the wave is v, and it moves for the time t. So the wavefront is moving with v into t time. Okay, so the tangent of the waves are joined together, and that forms the secondary wavefront. Okay, tangents of the line forms means that is considered the secondary wavefront. A dash and V dash is the secondary wavefront that we can consider over here by crossing the time V into t. So each of the point it propagating from a particular point, it may be going in front direction also, in the backward direction also. But in the backward direction, if you join all the tangent of the backward rays, that also gives one of the wavefront, but we are not considering this back side of the wavefront. We are considering only the forward direction, because in the previous video we have already studied that wavefronts will not come back. It will go propagate in only for one direction, not on the negative direction that we have already seen. So positive direction only that we will consider over here, not in the negative direction. So in the front direction where it moves means it is V into T. Backward direction it is considered as 0. So front tangent line which is joining over here is considered as T. Okay. So if we consider this the same thing as a plane wavefront, this is a plane wavefront. Each of this point, each point of the plane wavefront A and B, your waves are originated from a particular position. These are the dots where the light sources originates. It's point sources. The waves are started created, and it is moving from one point to another point. Okay, while it is moving from the time t into 0, it is moving to v into t. V is the speed of the wave, t is the time taken for the move from one point to another point. So this is first wavefront, this is the